In this video, I'm going to answer question number 9 from chapter 4, the purple paper. This is the molarity stoichiometry. So this question gives us a lot of information. If 234.7 milliliters of a 2.50 molar solution of copper 2 sulfate, that 2 should be in parentheses, I apologize, is allowed to react with a piece of aluminum, calculate the mass of the copper that is produced. So, as always, please underline or highlight the most important information, which is a lot of information. So I want you to notice this word react. A reaction is happening, so before we do any calculations, we need to figure out what reaction is happening. So we're going to take our reactant, so it says copper 2 sulfate reacts with aluminum. So copper 2, remember that means copper has a +2 charge. Sulfate is one of the polyatomic ions that has a -2 charge. So we would need 1 copper and 1 sulfate. And notice this word solution, it gives us this hint that this is going to be aqueous. And it will react with aluminum. Now we know that this is aluminum metal, so that's a solid. And what will it form? Well, aluminum is a metal and copper is a metal, so they're going to swap places. But I want you to remember that aluminum always has a +3 charge. So sulfate has a -2 charge. So our products are going to be aluminum sulfate, but we need to balance those charges. So if aluminum is +3 and sulfate is -2, we need 2 aluminums and 3 sulfates. And what will be left over? Copper. So plus copper, and that is a solid. That's metal. And we can assume that aluminum sulfate will be aqueous because it's only mentioning that we're just calculating the mass of copper that's produced. So the first thing we need to do with this equation is balance it. So we have 1 copper on the product side, 1 copper on the reactant side. That looks good. We have 1 sulfate on the reactant side, 3 sulfates on the product side. So let's add a 3 there. 2 aluminums on the product side, 1 aluminum on the reactant side. And now we've changed the number of coppers. So we have 3 coppers on the reactant side, so we need a 3 there. Okay, now we're ready to start answering this question. So we are told that we have 234.7 milliliters of a 2.50 molar solution of copper 2 sulfate. So we're going to start just by writing out what we have. So molarity equals moles over liters. And we are given 2.50 molar equals moles of copper sulfate, copper 2 sulfate, per liter, and we have 234.7 milliliters, so we divide that by 1,000 and we get 0.2347 liters. So right now our first step is going to be to solve for the moles of copper sulfate. Once we have moles of copper sulfate, now we need to look at what we want. We want the mass of copper that's produced. So once we have moles of copper sulfate, we can go from moles of copper 2 sulfate to moles of copper into grams of copper. So let's set this problem up. First, we're going to solve for moles by doing 2.50 times 0.2347, and that will give us 0.587 moles of copper 2 sulfate. So we take the moles of copper that we have calculated, that 0.587 moles of copper sulfate, and we convert it from moles of copper sulfate into moles of copper using our mole ratio given in the balanced equation. And then we multiply by 1 mole of copper per, oops, that's not right. Then we multiply it. We need to get our units to cancel. So moles of copper sulfate cancel with moles of copper sulfate, so we need moles of copper on the bottom and grams of copper on top to get to grams. So that's going to be 1 mole of copper for every 63.55 grams of copper. So that, after plugging that in our calculator, you should get 37.3 grams of copper as our product.